Bismillah ar-Rahman ar-Rahim and Assalamu alaikum to you all. On behalf of DHA Education System, I welcome you all in my computer science class. Course code is 2210. In week 4 for class C1, format of this session will be carried out by taking review of the topics covered in week 3, that is communication and internet technologies. Then the topics to be covered in week 4 and their learning objectives will be discussed. Content will be explained through numerical and theoretical representation. In the end, quick recap of the topic covered will be taken, and you will be given an assignment in the end that you can download from DHA portal to solve. In week 3, we talked about data transmission. Data transmission is the transmission of data between source to destination. Source is usually known as sender, while destination is usually known as receiver. Data is sent through wire or through wireless medium. Data in the form of binary is transmitted. It is first encoded, then the signals are processed, and then data is decoded to get the message at the receiving end. After that, we talked about 3 modes of communication: simplex, half-duplex, and full-duplex. These 3 modes of communication basically emphasize on the direction of the flow of data. So, in simplex data transmission, data is sent from sender to receiver in one direction only. Example is television broadcast. In half-duplex data transmission, data is transmitted from source to destination or from destination to source, but one at a time. Example of half-duplex is walkie-talkies or wireless communication. While in full-duplex data transmission, data is sent from sender to receiver or from receiver to sender simultaneously in both directions. Example of full-duplex data transmission is telephonic communication or video conferencing. After that, we discussed about 2 types of data transmission. One is serial data transmission and the other one is parallel data transmission. In serial communication or serial data transmission, data is sent in the form of byte, but one bit is sent at a time over a single wire. So data here sent bit by bit over a single wire from sender to receiver. While in parallel communication, data is sent in the form of byte, but all of its 8 bits are sent simultaneously from sender to receiver using 8 parallel lines that are usually known as wires or data paths. Serial data transmission is best used over the longer distance when there are less chances to intermingle the signal, while parallel communication is best used for smaller networks. Then we talked about asynchronous data transmission and synchronous data transmission. Both of these are the type of serial data communication. In asynchronous data transmission, bulk of data in the form of bytes are sent over a single line. Each byte is distinguished with the other by the use of control bit. At the start of the byte, which is the extreme right side, a control bit is added, which is known as the start bit. At the end of the byte, another control bit is added, which is known as the stop bit. This is how bytes are distinguished. In synchronous data transmission, there is no control bit used. However, data is sent in the bulk in the form of bytes over a single communication wire in the continuous stream of bits. There is a time session set between the sender and receiver for each byte. In the end, we talked about the universal serial bus or USB cable as the faster communication medium. Now let's discuss the topics of week 4. In week 4, we will cover the following topics from chapter number 2: error checking and detecting method, validation techniques, check digit method, verification techniques, parity check method, checksum method, automatic repeat request, echo check method. By the end of this lesson, students, you should be able to define error and error checking, Explain validation techniques by listing various validation checks. Practice check-digit method. Explain verification techniques by listing various verification methods. Practice parity check method. And describe checksum, automatic repeat request, and echo check method. So let's start the topic. Error detection. Before detecting an error, we need to know what is error. Error is a condition when the output information does not match with the input information. During transmission, digital signals suffer from noise that can introduce errors in the binary bits traveling from one system to other. That means a 0 bit may be replaced with 1 and a 1 bit may be replaced with 0. There is always a chance that data has been corrupted, changed in some way during transmission. This is true regardless of the distance of transmission. To avoid having corrupted data, it is really important that computers check for errors and correct them wherever possible. There are several methods for error checking and detecting, with some being more effective than others. Validation techniques. Validation is a process of checking if data satisfies certain criteria when input, that is, falls within accepted boundaries. Examples of validation techniques include various checks, for example, range check, length check, character check, format check, limit check, presence check, consistency check, and check digit. These are the different checks that can be applied on the data fields. Range check. This checks whether data is within given or acceptable values. For example, checks if a person's age is greater than 0 but is also less than 140. Length check. This checks if the input data contains the required number of characters. For example, if a field needs 6 digit, then input 5 digit or 7 digit, for example, should be rejected. Character check. This checks that the input data doesn't contain invalid character. For example, a person's name shouldn't contain number. Format check. This checks that data is in the specified format or in a specified template. For example, picture check. Data should be in the form of date format. For example, day should be entered first, then month, and then year in 4 digits. Limit check. This is similar to a range check except only one of the limits boundaries is checked. For example, input data must be greater than 10. Presence check. Presence checks check that data is actually present and not missed out. For example, in an electronic form, somebody's telephone number may be required field. Consistency check. This checks if fields corresponds or tie up with each other. For example, if cross-field check Mr. has been typed into the field called title, then the gender field must contain male or character M. Then the last one, check digit. This is an extra digit added to a number which is calculated from the digits. The computer recalculates and validates the check digit following input of the number. Check digits can identify 3 types of error. Number 1, if 2 digits have been inverted or transposed. For example, 23459 instead of 23549. Number 2, an incorrect digit entered. For example, 23559 instead 23549. And number 3, a digit missed out altogether. For example, 2359 instead of 23549. So basically, these 3 errors are known as transposition error, transcription error, and transmission error. Now let's see what is check digit method and how to calculate the check digit. A check digit is the final digit in the code of numbers. It is calculated from all the other digits in the code. Its purpose is to spot human errors on data entry. Check digits are often found in barcode, product codes, or ISBN book numbers. There are many different mathematical algorithms that can be used to calculate a check digit. Different industries will have their own predefined method. Let's see the method. Number 1. The check digit is calculated and added to the barcode, packaging, product code, etc. at the point of manufacturing. A human types the long numerical code into a computer. For example, the cashier will type the barcode number when a scanner fails or packaging is damaged. The computer calculates what it believes should be the check digit based on the number entered by the human. Number 4. The computer then compares its calculated check digit with the check digit typed in by the human. That is usually the last digit in the long code. If the two don't match, then the human has made an error when typing in the numerical code, for example, barcode number. The human will be asked by the computer to re-enter the numerical code. Now let's see how to calculate the check digit. Let's consider this example. In this example, we are given an ISBN number, which is usually used on book. We will be using Modulus 11 system, which includes letter X to represent number 10. So in this example, we are given with an ISBN number 0201538082. And the question mark here shows that we are supposed to find check digit that we will add here. So now on each of the digit of ISBN, we are going to give a digit position. So we'll start from the extreme end, which is the question mark where we need to find the check digit. So we will put the digit position on these digits. Each digit is then multiplied by its digit position and the totals added together. In this way, we got the answer 98. Here 1 multiplied with question mark will give you nothing, but this is the digit position we need to cater. The total is then divided by 11 because we are using Modulus 11 technique, and the remainder, if there is any remainder, is subtracted from 11 to give the check digit. We were having the answer 98. We divide 98 with 11 and 8 is the quotient and remainder is 10. Now we will subtract this remainder 10 from the value 11. 11 minus 10 is equals to 1. This gives the check digit of 1. So the final ISBN number becomes 0201530821, which is the number with a check digit. This is how the check digit is calculated. Now let's take another example. But in this example, we are not going to calculate the check digit. Rather, we are going to check the correctness of the check digit that computer recalculates. So to check the correctness of a check digit, the computer recalculates it in this way. The ISBN number is given. This is a different ISBN number, and X is given at the end, which is the indication of the check digit. In step 1, the position of each digit is considered. So on the each ISBN digit position is entered. Then each digit position is multiplied with its number and the total added together. In this way, we got the answer 132. Here you need to keep this in mind that X, when will be multiplied with 1, will be giving you the answer 10, because in the previous slide we said that x is equals to 10. So we got the answer 132. In step 3, the total is then divided by 11. If there is no remainder, then the check digit is correct. So 132 will be divided with 11. We got 12 in quotient and remainder is 0. When we get remainder 0, it means that the check digit is correct. This is how you can prevent your data from possible errors like transcription error, transposition error, or transmission error. Verification techniques. Verification is a way of preventing errors when data is copied from one medium to another, for example, from paper to disk or CD, from memory to DVD, etc. There are a number of ways in which verification can be done. For example, double entry, visual check, parity check, and much more. In double entry method, data is entered twice using two different people. The data is only accepted if both versions match up, often used to verify passwords by asking them to be typed in again by the same person. Visual check. This is checking for errors by comparing entered data with the original document. This is somewhat similar to the proofreading, but is actually not the proofreading. Parity check. This is used to check data following potential transmission error. An extra bit is added to each binary number before transmission. For example, even parity makes sure each number has an even number of 1 bits. Now let's discuss what the parity check method is. Parity checking. Parity checking is one method used to check whether data has been changed or corrupted following transmission from one device or medium to another device or medium. A byte of data, for example, is allocated a parity bit. This is allocated before transmission takes place. Systems that use even parity have an even number of 1 bits. Systems that use odd parity have an odd number of 1 bits. To understand the concept of even parity and odd parity, let's consider an example. In figure 2.6, a byte is given. We need to set even parity and we need to set odd parity for this byte. In case we are setting even parity, we need to see how many number of ones are there. The number of ones needs to be even. The number of ones, if there are 2 number of ones, 4 number of ones, 6 number of ones, or 8 number of ones, in that case you will be setting the parity bit as 0, because you do not need to make the number of ones even. They are already in even form. So you will be adding the parity bit as 0. While in odd parity case, you need to see the number of ones that needs to be odd. If there are 2 number of ones, 4 number of ones, 6 number of ones, or 8 number of ones, then you will be putting 0. Otherwise, you will be putting 1 as a parity bit. Hope you understand the concept of parity bit, even parity or odd parity. At a time, you cannot apply both of the parity, whether you will be following the rule of even parity or odd parity to transmit 1 byte of data. Let's summarize the parity checking method. The sending and receiving computers agree the protocol to be used even or odd. The sending computer adds the correct parity bit to the binary data, either an extra 1 or 0. The sending computer sends the binary data including the parity bit. The receiving computer checks that to make sure the overall parity of the data received is as agreed, an even or odd number of 1 bits. If the parity of data is incorrect, the receiving computer will request that the data is transmitted again. This is how, when a bit is flipped, the error can be detected. But there is a drawback of parity check. If two bits are transposed, they change their places, then the computer could be fooled into thinking the data is correct and not corrupted. If two random bits change state, then the system could also be fooled. Parity block. This method of error checking is similar to a traditional parity check, except the data is arranged in a virtual table with parity bits added to each row and column. A single corrupted bit can be spotted at the intersection of a corrupted row and column. Multiple corrupted bits would also flaw the system. Now let's consider table 2.2. Here 9 bytes are given, 8 columns are also given. At the start of every byte, a parity bit is added. So let's see whether according to the even parity bit rule, the parity bits which are set are correct or not. In the first row, if we just count the number of ones, there are 5 number of ones. So 5 number of ones means the number of ones are not even. If the number of ones are even, we will be setting the parity bit as 0. Here the number of ones are not even, so to make it even, parity bit is set as 1. So it is correct. In the second row, there are 3 number of ones and the parity bit is set 1 to make it even. In the third byte, there are 6 number of ones, which are already even number of ones. So the parity bit is set as 0, which is correct. In 4 byte, there is total 1 number of 1. So the parity bit is set as 1 to make it even, which is correct. In byte 5, there are total 4 number of ones, which are even. So the parity bit is set, which is 0 and is correct. At 6th row, byte 6, there are total number of 1 number of ones are there. So to make it even, 1 is added as a parity bit, which is correct. At byte 7, there are 5 number of ones. So to make it even, 1 is added as a parity bit. It is also correct. At byte number 8, there are total 5 number of ones, which are not even. So to make it even, the parity bit should be 1. Instead, here it is written 0. So this is the wrong parity. In byte 9, there are 2 number of ones, which are even. So we do not need to add any 1. So the parity bit will be set as 0, which is correct. In the last byte, there are total 3 number of ones. So to make it even, 1 parity bit is set, which is correct. Now let's consider each column. At the first column, which is the parity bit column, we need to see that there are 5 number of ones. 5 number of ones, and to make it even, 1 is added in the last row, which is correct. In the second column, there are 3 number of ones. So to make it even, 1 is added, which is correct. In the third column, there are 4 number of ones, which are already even. So the parity bit will be set as 0, which is correct. In the fourth column, there are 5 number of ones, and to make it even number, we need to add 1. So 1 is there, and this is also correct. In column 5, you need to see there are 5 number of ones. So to make it even, we need to add 1 here. But if you just look at the last row, in the fifth column, 0 is there. So it means this column contains some error because parity is wrong. In the next column, 4 number of ones are there and the parity bit is set 0, which is correct. Then in the next column, 6 number of ones are there and the parity bit is set 0, which is correct. Then in the last column, there are 3 number of ones, and to make it even, 1 is added. So this is correct. So in this way, we found that in byte 8 and in column 5, there is an error in the parity bit. When these two columns intersect, there is a bit 1. If we just change it to 0, this will rectify the error. Now let's discuss another error checking method. This method is named as checksum. A block of data is sent alongside a calculated checksum value. The receiving computer also calculates what it believes should be the checksum. The checksum values are then compared to see if an error has occurred during the transmission. Now let's see the stepwise procedure to find the checksum method. Number 1. The sending computer uses the block of data to be sent and a predefined mathematical algorithm to calculate a checksum value. The sending computer sends the data plus the checksum value. The receiving computer uses the data it receives to also calculate what it believes should be the checksum using the same mathematical algorithm. The two checksum values are compared by the receiving computer. Due to the nature of algorithm, it is highly unlikely that corruption has occurred if the checksum values match. If the checksum values don't match, the receiving computer requests that the data is transmitted again. Students, in your book, there is a different checksum method given. There is no particular requirement to calculate the checksum, so we are not going to solve any numerical example of the checksum method. Automatic repeat requests. This form of error detection uses a system of acknowledgements and timeouts. Automatic repeat requests are often used to ensure reliable transmission over an unreliable service. Let's see the stepwise procedure of automatic repeat request. The sending computer transmits a block of data. The sending computer waits a period of time to see if the receiving computer acknowledges receipt of the data. After a set of period of time, a timeout occurs which triggers the data to be automatically resent by the sending computer. This will continue until the receiving computer acknowledges the data has been received. Echo check. With an echo check, the receiving computer sends a copy of the data immediately back to the sending computer for comparison. The sending computer compares the two sets of data to check if any error occurred during the transmission process. If an error has occurred, the data will be transmitted again. However, there are few drawbacks of echo checks. If the two sets of data are different, you will have no way of knowing whether the error occurred when originally sent or when it was sent back. Echo check requires a lot of extra data to be transmitted. That is it for today's lesson. Let's take a quick recap. Today we discussed about error and error checking. We discussed about validation techniques and verification techniques. In validation techniques, we discussed about various checks. Validation basically is a process of checking if data satisfies certain criteria when it is input. For example, whether it falls in the accepted boundaries or not. In validation techniques, we discussed about range check, length check, character check, format check, limit check, presence check, consistency check, and check digit. Check digit is the method which is used to rectify three types of error. Number one, transcription error, when you are entering something and you have entered it wrong. Transposition error, when two of the digits are replaced its value. And number three, transmission error. We also solved an example to calculate the check digit, and we also solved another example to recalculate the check digit to see whether the check digit is calculated correctly or not. Then we talked about verification method. and verification techniques. Verification basically is a way of preventing errors when data is copied from one medium to another medium, or whether it is from paper to disk or from memory to your USB or any other device. So there are various methods to verify the data. For example, double entry is a method to verify whether the data entered is correct or not. Visual check method, parity check method. Parity check method is a method in which a parity bit is added at the start of one byte before transmitting that byte. So we discussed two rules of parity bit: even parity and odd parity. After that, we discussed about the checksum method. Checksum method Checksum method is a method which is used to check or detect the error on a block of data. So a block of data is sent alongside the calculated checksum value. The receiving computer also calculates what it believes should be the checksum. So the checksum values then are compared to see if an error has occurred or not during the transmission. After that, we discussed about ARQ, which is automatic repeat request. This is the error detection method, which uses two things. One is the acknowledgement and other one is the timeout. So basically, the user keeps on sending the data, and when it is not getting the acknowledgement from the receivings end, it will keep on sending the request. In last, we discussed about the echo check method. With an echo check, the receiving computer sends a copy of the data immediately back to the sending computer for comparison. So the sending computer compares the two sets of data to check if error occurred during the transmission process. That is it. Now you can get the practice questions in the form of assignment from the DHA portal. You can download those questions and solve it over the weekend. Thank you so much for your attention.